An urn contains three balls, one black, one red, and one white. Balls are selected with replacement from the urn until at least one black, one red, and one white has been seen. What is the chance that we make four draws from the urn? So in this problem, I'm going to use these colors because they show up better. So this is kind of a sea green, I guess, turquoise. Let's call it green, purple, and yellow. So if we make four draws from the urn, then sequences like the following are allowed. So we can have our green, green, purple, yellow. That's allowed, right? Because we have to see two of one of the colors within the first three, and then one on the fourth. We can't have something like yellow, yellow, yellow. No sequence that has this that is three of the same color will allow us to make four draws because we need at least two more. And then we certainly can't have sequences like green, purple, yellow, right? So none of those are cool, but ones like this are, right? We can have two of one color, one of another color on the first three draws, and then getting the remaining one on the last draw. So how many possible ways are there to make sequences like this? So we have our first three, and then our fourth, and this can't appear in here. Okay, so let's look at it from this perspective. If I have green, green, purple, how many possible sequences are there? Well, there are 3 factorial ways to arrange these three balls. But these two are the same, so we have to divide by 2 factorial, and we're left with 3 possible ways to arrange the first three balls. And this would be the same for any pairing of colors. So how many possible pairings of colors are there for the first three balls? So how many color pairings are there? How many color pairings? Well, there are 3 choose 2 because we have to pick 2 colors, and 3 choose 2 is just 3 factorial divided by 2 factorial, but this isn't correct, right? Because the order matters. Which one we see 2 of matters. So we have to multiply this by 2, right? Because getting green, green, purple is different from getting purple, purple, green. Those are different possible sequences of balls. So what we're left with is 6 possible color pairings for the first 3 balls. So how many valid sequences are there? Well, for the first 3 balls, there are 6 possible color pairings where we can get 2 of one color and 1 of another. So 2 of one color and 1 of another. And for each of these possible pairings, there are 3 possible sequences. There's 3 ways to arrange them. So 3 ways to arrange them. So what is the probability that on the first 3 we get a sequence that allows that's even possible to finish on the fourth? Well, we have 6, and then we have 3. And how many possible sequences are there? Well, there's 3 to the third because we have 3 possibilities for the first ball, 3 possibilities for the second ball, and 3 possibilities for the third ball. This leaves us with, well, this is just 2 times 9, right? Divided by 27, which is 3, right? 27, which is 3 cubed. So this gives us 2 times 2 times 1 over 3. So there's a 2/3, so there's a 2/3 possibility of us ending up in a valid sequence that could let us finish on the fourth draw. Well, on the fourth draw, if we're in one of these valid sequences, what's the probability of getting one of the balls, or the color of a ball that we haven't drawn yet? Well, that's always going to be 1/3 because we've drawn 2. So what are we left with? We're left with 2/3 times 1/3, and that's 2/9. Right? And just to make sure that this is correct, if we look at what's the probability of a sequence where we get 3 of one color, so 3 of one color, well, there's 3 ways to get that, and each of those sequences has probability 1 over 27, so that's a 9th. And then the probability of getting all 3, well, there's 3 possible ways to arrange it. Sorry, 6 possible ways to arrange it. 3 factorial. And then that's also times 1 over 27. So that's 2 times 3 over 3 cubed. So that's equal to 2/9. Right? This is 2/9. This is 1/9. Add these together, you get a third. Right? So this calculation checks out. So there's a 2/3 chance that we get 2 balls of one color and 1 ball of another color on the first 3 draws, and then from there we say, well, the fourth draw is independent, so the probability of getting a ball different color is a third in any of those cases, and we're left with 2/9 probability of making exactly 4 draws.